Thank you for coming to my talk. This is Michael from Brevis. Today I'm going to talk about how we can achieve the next 100x for Ethereum layer 1, and specifically using some technology called zero knowledge proof. Okay. So blockchains themselves, including Ethereum, are often marketed as world computers. But if you really think about it, when we're talking about a blockchain, it cannot run faster than a single server. And it is also very extremely expensive to actually process transaction on this world computer. Well, you may say, okay, that's not the case because there has been so many different development over the years on scalability. So we should be able to process just about anything on blockchain, right? Well, unfortunately, that is not the case. Let me give you a very simple example here. On every centralized exchange, you all have this very simple feature where you trade a lot in this month, and in next month you get a trading fee discount. Very simple, right? But if you look at any of the decentralized exchanges, none of them has this feature. Why? It's not because this feature doesn't work. This is a bread and butter feature for centralized exchange to retain user, but because it is actually extremely expensive to build. And there's no way that it can build trust-free access and computation on historical data on-chain without actually breaking banks. So why is that? Well, it is actually rooted in how Ethereum consensus and every blockchain's consensus work today, which is based on something called replicated computing, right? So we're talking about blockchain, and blockchain is all about multiple different nodes achieving consensus, which is an agreement on some computation result. Right, so let's say we have a blockchain of two nodes, Alice and Bob here, and they're trying to achieve consensus on the result of this kind of multiplication equation. So how do we do this? Is by doing replication of computation. So Alice did the computation once, and how can Alice convince Bob this is the correct result? Well, simple. Bob will just do the computation all over again. So you can see the problem right now because what happens here is that if we want to have a very, very decentralized blockchain, it means that we need to replicate and repeat the same kind of computation again and again. So, it seems that swapping a token from A to B is pretty simple, but what happens on a global scale is that you're actually doing the same kind of computation millions of times on Ethereum. This is a fundamental reason why Ethereum is slow and the challenge we need to solve here today. So how do we solve that? Well, we introduced a new computing paradigm called verifiable computing. In the realm of verifiable computing, you have different roles in the computation process. You have someone, which in this case is Alice, called a prover. So Alice is not only just doing the computation itself, but also generating something called a zero knowledge proof on top of this computation. Now, this proof is a mathematical magic that you can use to send it to any verifier, and the verifier can just verify the proof of the computation with extremely low cost and latency, with tiny amount of computation power. So this kind of a verifiable computing allows you to decouple computation from the verification process, which gives us a new tool to build a new generation of blockchain, a new kind of consensus that doesn't actually rely on repeated computing. And the nice thing about verifiable computing is that the proof itself is always a constant piece of data that you can verify no matter how complex the original computation is. So this is what Brevis is, a whole premises is. We are building a verifiable computing engine that allows you to offload very complicated and repeated computation on blockchain to an off-chain engine. And in this off-chain computing engine, you can do the computation, generate a zero-knowledge proof, and send it back to blockchain, either to the validators or the smart contracts on blockchain, so that they can verify the computation easily with extremely low cost. So this is not a prototype or concept. In fact, many of the applications today in blockchains and different kind of chains are already using product and the verification engine built by Brevis. So I talked about what is actually the concept and who are using us. So what is actually inside this magic verifiable computing box? Well, in the center of this is something called a Pico ZK VM. So Pico is a zero-knowledge virtual machine that allows you to prove computation of any software. Any software, that's the important part, right? So it's a RISC-V ISA-based virtual machine. And that allows you to, instead of writing your own ZK circuit and know the underlying mathematical concept and the cryptographic concept of a zero-knowledge proof, you can now just write very simple, high-level programming language of the software you want to prove, like, for example, using Rust. And, and then, boom, it's become a verifiable computing program. Now, as I mentioned, this really allows us to change how blockchain operates today. So instead of every validator, millions of them in Ethereum compute the same exact thing over and over again, now you can have just one node, one prover, does the computation, generate the proof, and send it to everyone in the Ethereum blockchain to just verify it. And verification, as I mentioned, is extremely low cost and low latency. So you can even use your mobile phone to act as a Ethereum full node in the future. This is very powerful. And what this enables us is really infinite amount of scalability because you can put a lot of work on this single prover node while everyone else just stays as very simple and kind of a low overhead layer. So the most important thing to enable this is, of course, performance of the verifiable computing layer itself. So you need to at least generate proof of Ethereum blocks execution as fast as the block is produced, right? So today, we are actually achieving a 99% Ethereum real-time proving capability. Means that we can generate proof for Ethereum block computation within 12 seconds for 99% of the blocks on Ethereum. The latest block, 6 million gas, with just 2 GPU cards. And with more GPUs, we can actually achieve infinite amount of scalability easily because the whole Brevis Pico ZK VM system is what they call embarrassingly parallel. Means that you can just add more machine to get more capacity. So, this is how you can enable Ethereum scalability. And, we're actually doing this with, Ethereum Foundation and many others in the ecosystem as well to power and upgrade Ethereum from the current consensus system to a zero-knowledge proof-oriented one. But you can already use Brevis, and as I mentioned, like a lot of different applications are using us today, using, our kind of a verifiable computing engine without upgrading the underlying blockchain by augmenting the verifiable computing engine with your application. So the most recent, kind of a example of this is not actually related to blockchain. So this is something that we built recently called Brevis Vera. So we all have this kind of a problem today that you cannot tell, if you see something on social media, whether this kind of a picture or video is actually real or not. Right? So, and using AI to actually detect whether something is generated by AI is a losing game because you're just doing arms race with other AI models. So instead of doing that, we use ZK to allow you to prove that a certain picture and digital media is actually generated from a real authenticated device. Right? So like you have something on your device today. Many of the devices have that. Some phone has this, like a Sony, kind of cameras has this that allows you to sign your photo when you're actually taking it, sign the raw image. So what's the role of ZK here is that ZK allows you to generate a auditable trail to show that the final photo, the final edited photo you show to the world is actually coming from a real device capture instead of generated by AI. So this actually got a lot of kind of a positive response from the community, and we're talking to some of the largest consumer-facing brand, working on kind of a video editing and photo editing tool to enable this in this tool and workflow, so that in the future you can see that a video is posted online, and there's a very simple way for you to verify if it actually came from a real capture. So, in the blockchain realm, we have been working with numerous top projects like PancakeSwap, for example, enabling intelligent DeFi, the kind of a feature I talked about, the dynamic user, feature and experiences based on historical user behavior. And Aster recently released their Aster chain. We are actually powering the privacy feature on the Aster perpetual swap. So now you can actually send privacy preserving orders on Aster without revealing your whole position. And we are actually protecting that using our zero knowledge proof technology. And more recently, we are also enabling this kind of a ZK credit system on BNB chain in collaboration with Lista.DAO to enable you to generate proof of your Web2 identity to show that, okay, I'm actually a GitHub owner. I'm also for example, Upbeat user with a KYC account. I have traded a lot in the last year. And with all these kind of information authenticated and tested, you can now use these kind of attestation as a way to do credit lending on chain, which was not possible before. And we're kind of actually enabling this with the collaboration with BNB chain team and some of the lending protocols there. So another big category of use case that we do is stable token growth. So on Ethereum, there are so many different stable tokens, and I think there are going to be more. And but the problem is always distribution. Once you launch a stable token, the next question you need to ask is like, how do you actually allow the user to actually use these stable tokens, right? So how do you get adoption? How do you kind of distribute the tokens to different DeFi protocols? And this is what we do, that we build a distribution program that is fully powered by ZK, that is compliant, and you're not just like as a stable token issuer sending tokens to end users like blindly, and also provably transparent and fair for the users. So we're also helping a lot of new chains launch, like Linea's blockchain's entire launch program is also powered by ZK-based and ZK-powered reward program and systems. And MetaMask cards launch is also powered by us. So my prediction is that in 10 years, really 99% of computation for blockchain applications and also blockchain infrastructure themselves is going to happen off-chain and hopefully verified by ZK proof and by us. So the final piece of this is something called Brevis Prover Net. So Brevis Prover Net is right now live that allows you to actually access the infinite amount of computing power in the ZK proving stack. So you can really just send any kind of a proving request easily to send any kind of a proving request you want to the entire prover network, and you don't actually need to host any GPU locally or have your own infrastructure. So this way, we really kind of make the entire proving system and the proving pipeline decentralized and highly available. Cool. That's all for my talk, and thank you, everyone.